What you want to do today?
Sir, just 1 second. Just 1 second. I'm just getting the book sorted.
Okay.
Yes, sir, I'm back.
Yeah, what topic you want to do today? Tell me.
Uh, I think that same topic that we were doing last time, can we continue it? Units and measurements. We had stopped at sum of reciprocals, I think.
Units and measurement I have completed, na? What topic is left there?
Okay. Then it seems that Akash is holding a test on 5th December. So, sir, just let me take out the test topics of that.
Okay, which are the topics?
Yes, sir, I'm checking that on. There will be a system of particles and rotational motion, but we haven't started either of the two chapters yet, so it's still kind of confusing.
System of particles, they have started teaching. Akash, no, they have not
But
started.
they have not started also, that's the
Okay,
but
fine.
we have
So
test papers
when you have test? At what date?
6th and 7th December.
Okay. Should I start
It's
that chapter then?
one of the 2 days. Yes, sir. Yes, sir.
Okay. System of particles and rotational motion. First topic in this chapter is about center of mass. So let's discuss first about center of mass. Now, definitely it is a that point. It is the point where total mass of a system, total mass of a system, total mass of a system is supposed to be concentrated, is supposed to be concentrated. That point is called as center of mass of the system. How we can find the position of center of mass? How I can find the position of center of mass. So for that, let's take a coordinate system. And I take few points M1, M2, M3, let's suppose M4, and such. I have n bodies. This is the origin. First, M1 is having some position vector. Let's suppose M2 is also having its position vector. M3 is also having position vector. M4 is also having position vector. And let's suppose such that I can say that Mn is also having position vector. This is M. This is Mn. This is the first particle here present, that is M1. Second particle here present, that is M2. Third particle I have taken M3. Fourth particle I have taken M4. And nth particle. This is the coordinate system. This is our x-axis. This is the y-axis. And z-axis I cannot draw on the line. So let's suppose this here it is z-axis coming out of the plane. M1 has a position vector R1 vector. M2 has a position vector R2 vector. M3 has a position vector R3 vector. M4 has R4, and similarly Mn is having Rn. Do you understand the diagram, Neil?
Yes, sir.
Okay. So the position of center of mass, that is RCM, will be, you also write with me, okay? So you will get acquainted with it.
Yes, sir. I'm
So
writing.
M1 R1 plus M2 R2 plus M3 R3, and this will go up to last particle Mn Rn, and that divided by total mass of the system, that is M1 plus M2 plus M3, and that will go up to Mn. That's how you find the position vector of the center of mass. Now, position vector, if this is in vector form, if you are trying to find the coordinates of center of mass, individual coordinate if you are trying to find, that also we can find. Coordinates of center of mass, then for x coordinate of center of mass, I need to use m1 x1 plus m2 x2 plus m3 x3, and that will go up to mn xn divided by total mass, that is m1 plus m2, and that will go up to mn. That is how you find x coordinate. You can also find y coordinate, that is m1 y1 plus m2 y2 plus m3 y3, and that might go up to the last particle, that is mny, and that divided by, always at the denominator you have to use the total mass of the system, that is up to n. You can also write the z coordinate in the same pattern. that is m1 z1 plus m2 z2, and that will go up to mn zn divided by the total mass, that is m1 plus m2 plus m. Do you understand how to find center of mass, Neil?
Yes, sir.
Okay, now let's few examples here. If I'll say I have two particles, here one particle, here one particle. Let's suppose this particle is of mass m1, this particle is of mass m2. M1 value I can put here 2 kg, and m2 value I put here as 4 kg. And the distance between them is given as this r. Let's suppose it is given as 6 meter. And they are saying that locate the center of mass. Where is the center of mass, that you have to find. Locate the center of mass. Now, if center of mass we have to locate, I have to use first coordinate system. So a coordinate system first, that means you have to take this as the, or any point you can take the origin. Whatever point you can take 2 kg as the origin, 4 kg as the origin, any mass you can take as the origin. So let's suppose here I am taking this as the origin, and this I write as the origin 0 0. So if I'll take this as x-axis, y-axis is not needed here because all the particles are along x-axis only, so y is not needed. So in this case, the 4 kg has a coordinate. This distance is 6, so its coordinate will be 6 comma 0. 6 comma 0. So here I have to find only x coordinate of center of mass because both particles are only on the x-axis. The formula I have to use this m1 x1 plus m2 x2 is divided by m1 plus m2, and m1 I'll take as 2 kg, x coordinate is 0. m2 I'll take as 4 kg, x coordinate is 6, and divided by this is 2 plus 4. So I'm getting here 24 by 6. That means answer is 4 meter. That means center of mass will lie at a distance 4 meter from 2 kg. Okay, this distance will be 4 meter. And similarly, if this is 4 meter, then this should be 2 meter. 2. So the center of mass coordinate I have found as 4 comma 3. Do you understand this example, Nil?
Yes, sir. I'm good. I'm understanding.
Okay. You can also note a point here that center of mass is close to the heavier body. You can say the center of mass is near the heavier mass. Whoever is the heavier mass, center of mass will be close to that body.
Sir, could you just scroll up for 1 second? I did not read that first. Huh.
Okay. Okay. Is right.
Okay, sir. Done.
Okay. Let's take one more example. If I have, let's suppose, three bodies and they are kept in an equilateral triangle like this. This is A, B, C. The masses I have kept on the vertices here. Like here, let's suppose I have kept M1 is equals to 2 kg. Here I have kept M2, that is 3 kg. And here I have kept M3, that is 5 kg. And this is here 4 meter. This is 4 meter. This is, let's suppose, 4. And we have to locate the center of locate the center of mass. Now, for the first, we have to take the origin. So normally the uh, left particle always we take as the origin. So if this I take the origin, then this becomes x-axis, and this can become as y-axis. So I can write the coordinates. If B is origin only here, so its coordinate will be 0, 0. This is 4 meter, so this coordinate will be 4, 0. And this M3 is will be at the midpoint only because it's an equilateral triangle. So 4 half x coordinate will be 2 here, and y coordinate will be height of this triangle. I know that height of any equilateral triangle is always formula is root 3 by 2 multiplied by side. Side is given 4 here. So h I can write root 3 by 2 into 4, and that will be 2 root 3. Okay, that is 2 root 3. So here 2 comma 2 root 3 is the coordinate of the third particle. Writing the coordinate of all particles is very, very important. Then only you can you will be able to locate the center of mass. So now we have identified the coordinates of the three particles. So I can write now the center of mass x and y coordinate both I have to find, because particles are not only x axis, it is away from x axis also. So first let's try to find x coordinate of center of mass. This will be m1 x1 plus m2 x2 plus m3 x3 divided by total mass, that is m1 plus m2 plus m3. So m1 here is 2 kg, x coordinate of 2 kg is 0. M2 is 3 kg, x coordinate is 4. M3 is 5 kg, x coordinate is 2. Divided by mass is 2 plus 3 plus 5, that is 10 only. 12 plus 10, 22 by 10. That means be x coordinate is 2.2 meter. X coordinate is 2.2 meter. Similarly, I can try to find the y coordinate. The y coordinate formula I am going to use as three particles are there. So m1 y1 plus m2 y2 plus m3 y3 divided by total mass, that is m1 plus m2 plus m3. Now m1 y1, m1 is 2, so I can say here 2 into 0. M2 is 3, is also 3 into 0. Second particle is also on axis only. And third particle 5 kg, y coordinate is 2 root 3. So I can write here 5 multiplied by 2 root 3. Divide, total mass is 10 only. So here I am getting 5 root 3. Sorry, 5 into 2 root 3. So I can say 10 root 3. 10 root 3 by 10. 10, 10 cancel. So I get root 3. Root 3 I can write as 1.7 meter. So I got the x coordinate, I got the y coordinate. It means center of mass, I can write the coordinates as 2.2 comma 1.7. If you need to find the position vector format, so you can also write as 2.2 I cap and plus 1.7 j cap. Do you understand, Neil?
Yes, sir.
Okay, have you copied?
Yes, sir. And the last thing.
Okay.
Yes, sir. Done.
Okay. So even two particles, three particles were there. Now I think you will able to find the center of mass, right?
Yes.
Okay. So sometimes we have not point masses. We have a continuous body like a rod or ring or a plate or rectangular plate or sphere, cylinder. This type of body for a continuous body. For a continuous body. How to find center of mass? If bodies are symmetrical, if bodies are symmetrical, then center of mass lies at their geometrical center. Their geometrical center. For example, let's suppose I have a ring, disc, sphere, this type of body, or I have a triangular equilateral triangle, or I have a square, or I have a rectangle. In all conditions, these are symmetrical only. So their center of mass will be at their original center. Here will be center of mass. Here centroid will be center of mass. Here this point geometrical center will be center of mass. Here this point will be center of mass. So if the bodies are symmetrical, then you can write that their geometrical center is also their center of mass. Okay.
Yes, sir.
But if the body is not symmetrical, then you have to use the formula. for other bodies, for other bodies, the center of mass, if you are trying to find RCM, you should take a small element, try to find the center of mass of that first by taking a small element dm into r, and then as we divide by the total mass is the integration of dm, whatever dm we have taken. This you can write for x-axis, you can write for y. Okay, you can also, that means if I have to find the x coordinate, then I'll use the same thing. X I have to find, then I'll take a small m, multiply with the x dmx, and then divide by the total mass, that is dm. If I have to find y coordinate of center of mass, then I'll take a small element dm, multiply with y, and then divide with dm. So that is the technique that we use to find the center of mass for a continuous body which is not symmetrical. Understood?
Understood, sir.
I'll take one example to explain this. Let's suppose they say center of mass of a uniform rod. Center of mass of a uniform rod. Let's suppose I have a rod, uniform rod of mass m and length L. Let's suppose length L. This length is given as L and the mass is given as L. So first of all, you have to take one origin. Let's take this end of the rod I am taking as the origin. So this is my x-axis, and y-axis will not be needed because body is entirely along x-axis, but let's suppose again I am writing y-axis. So this is my origin here, 0, 0. Now first step is you have to take a small element. Let's take a small element. That small element I am taking here, a length I'll take dx. Dx means very small length, and x is the distance where I am taking it. So let's take a small element dx at a distance x from the origin. At a distance x from the origin. From the origin. So let's take a small element dx at a distance x from the origin. Now next step is you have to find what is the mass of this small element. If I take mass of small element, mass of a small element, that always I write as dm. Dm is the mass of small element. How we find the mass of a small element? That you have to check which type of body is this, and how the mass is distributed. So you can see that mass is, this is a one-dimensional body, only length is there. That means mass is distributed on the length only. So you can use the mass density. You can use the mass density. Lambda I can write, that I can write total mass by total length. So this is the density of the mass. So here dm mass, how we can find? I can find mass equals to density multiplied by length, because mass is distributed on over length only. So you can write dm equals to density into length. Now density I know is m by l, and the length of our that part that I have taken, a small element that I have taken has a length dx, so I'll write m by l into dx. That means in place of dm I am going to use m by l into dx. First terminal, up to here you have understood everything.
Yes, sir.
Up to here you have understood everything now.
Yes, sir.
Okay, now let's try to find the center of mass. Center of mass is an only x coordinate, so I'll use x center of mass. The formula says that I have to integrate dm into x, and I have to again integrate dm. Fine. So let's try to integrate first. Integration of dm is m by l into dx, and that multiplied by x divided by integration of m by l into dx, that is only dm. M by l you can take outside, so m by l I take outside, this is x dx, divided by here also I can take m by l outside, and that is dx. M by l, they are constant that you can cancel, and the integration that you have to go do is from this end to this end. This end is at distance 0, and this end is at a coordinate l comma 0. So limit will be from 0 to l. The limit of the integration will be 0 to l. Here I am writing, this is x dx 0 to l, and this is dx 0 to l. 0 to l, x is x square by 2, 0 to l, and dx integration is only x, that is 0 to l. So only you put the value of l, because 0 will give you 0 only. So you can write here l square by 2, and this is divided by only l. So that is l square by 2l, 1l I can cancel. So the center of mass I have found is at l by 2. That means center of mass of the rod will be actually at the midpoint of the rod. Here will be the center of mass. But that's how we derive the center of mass for the rod. Please check anything if you want
Oh,
to ask. Understood?
yeah, yes, sir. I've understood. I've understood. Just 1 second. I'm just writing this down.
Sure, sure.
Yes, sir. Done.
Okay. If let's suppose there are more than one rod. Like if I say I have two rods, like that, or one rod has been bent in L shaped, like that. This is also having length L. This is also having length L. And they are identical rods. So mass will be also same. So you can say that, or I can write one rod of length, one rod of length 2L is bent in the shape of L as shown. And I'll ask, what is the distance of center of mass from this midpoint? This midpoint is O. What is distance of center of mass from the midpoint? From the midpoint. So you can imagine the, if this is not point mass, these are the two rod continuous body only, like rod, ring, sphere. So in such cases, center of mass coordinate that you have to find, if you try to find x coordinate, you should use L1 x1. Okay, because the rod is made of same material, so you, in place of mass, you can only use length. L1 x1 plus L2 x2 divided by L1 plus L2. Coordinate system, you can make origin O, I'll make is as the O as origin. This I'll make as x-axis. And let's suppose this I am making as y-axis. So now you ask that what is x1, x2 here? So x1 is the x coordinate. X1 is x coordinate of center of mass of first rod. Center of mass of first rod. That means now I have to find the center of mass, and that coordinate I have to take. Like let's suppose this is the first rod, center of mass will be in the midpoint, just I have shown. So this coordinate will be here. This is complete is L. So this will be L by 2. So here x coordinate is L by 2, comma 0. Similarly, x2 is what? Is x coordinate of, is x coordinate of center of mass of second rod. Second rod. So second rod is this. So I can take the center of mass here. Okay. And this is also L by 2, but it is on y-axis. So coordinate I'll write 0, comma L by 2. X coordinate is 0 only. By using that, if I use this formula, L1 both is L only, L into x1 is L by 2. And this x2 is here 0. Divided by L plus L is 2L. So I am getting here L into L by 2 is L square by 2, and 2 will be 4 here. 4L cancel. So I got the x coordinate of the center of mass is L by 4. Similarly, I can try to find the y coordinate also. And y coordinate formula I know is L1 y1 plus L2 y2 divided by L1 plus L2. Now here y coordinate is 0 for the first rod. So I can write L into 0. And for the second, it is L by 2 only. So I can write L multiplied by L by 2 divided by total length is 2L. So it is also coming L by 4. So X coordinate is also L by 4, Y coordinate is also L by 4. And that will give you the L by 4 is here and L by 4 is here like this. So this is the position of the center of mass, which is a coordinate L by 4 X coordinate, L by 4 Y coordinate. But I have to find the distance from the center. Okay. So by Pythagoras theorem, I can find the distance because I know that this distance is also L by 4 and this distance is also L by 4. So this R distance I can find as a hypotenuse of the triangle. So I can use the formula distance from the center of mass. Distance from center of mass. I can find R by Pythagoras theorem. This is L by 4 square perpendicular square plus base square, L by 4 square. So I'll get here L square by 16 plus L square by 16, that is L square by 8. Under root if we will take, then L by under root 8. Under root 8 you can write as 2 root 2. So final answer is L by 2 root. Please check the steps, Neil, and tell me if any doubt you are having.
Okay, sir. Just 1 second.
Yeah.
Sir, as such, I don't have any doubts. No,
Okay. Have you completed writing?
no, not completed. The
Okay.
distance from blue. Yes, sir, done.
Okay. Sometimes they might say that rod is not uniform. So let's take one example on that also. If you have non-uniform rod, like the density is not constant, it depends upon some factor. Like it is given that the mass density of a rod the mass density of a rod is given as mass density is given as let's suppose lambda is given as lambda naught into x, where x is distance, where x is distance from the left end of the rod of rod. Like this type of rod is there. It is not uniform density. Okay. The density is changing if you go from left to right. So here lambda is given, you can see lambda is given as lambda naught into x. Lambda naught is a constant. So first of all, the end from where the reference has been taken, the left end that you take as the origin, this you write as y-axis, this is x-axis. So the rod is along x-axis only. So rod is along x-axis only. So I'll take, I'll only find the x coordinate, and x coordinate I can find as x center of mass is integration of dm into x divided by integration of dm. That is the rule that I am going to follow. So first nil I have to take dm. So let's take a small element here,
Okay.
and a small element I'll take of length dx, and that I'll take at a distance x from this end. Now dm formula I told you, the dm always I have to use the density. What is the mass density that has been given, multiplied by the length that we are trying to take. So density is given as lambda naught into x, and length that I have taken is dx. So that is the value of dm, and that I'll use in this formula, equation 1. So I can find that x center of mass, x center of mass is integration of dm. Dm is lambda naught x dx multiplied by x divided by integration of dm only. Dm is lambda naught x dx. Lambda naught I can take outside. It is integration of x square dx. And here also lambda naught you can take outside. This is integration of x dx. The total length of the rod is given as L. Let's suppose the length has been given as L. So you have to integrate from 0 to L. 0 to L. Lambda naught you can cancel. Now x square integration is going to be x cube by 3 from 0 to L, and x integration is going to be x square by 2 from 0 to L. So this will be basically L cube by 3 divided by L square by 2. I can write L cube by 3 multiplies by 2 by L square. L square is cancelled. So I get the x coordinate here. I get the x coordinate as 2L by 3. Now it is not midpoint. It is at 2L by 3. You can see the center of mass will lie at this point. Okay. It will be
Okay.
not midpoint. It will be slightly towards the right. Understood, Neil?
Yes, sir.
Okay. Please complete writing.
Yes, sir. Done.
Okay. Now, if you have laminar bodies. For laminar body is two-dimensional body which has not only length, they have area. Okay, so you can also use the center of mass coordinates RCM. You can also find by taking the area here, A1 R1 plus A2 R2 divided by A1 plus A2. But for that, body should be made of, for bodies made of same material, made of same material, bodies made of same material. Okay, so bodies made of same material, like they are made of steel, they are made of aluminum, whatever material you are using, they should be made of same material. And A1 A2, A1 and A2 are area of the bodies, are area of the bodies, area of the bodies. This formula also we can use. I'll take one example to explain this. Let's suppose I have a square like this, and I also have a I also have a disk. Okay,
Okay.
wait, yeah, like that. Now I have to locate their center of mass. Now this length has been given 2x, and its radius is given as x, and both are of same material. It is a square. If I am saying, then all sides are 2x only, same here. And they are saying that find the center of mass, find the center of mass in this example, or find the distance of the center of mass, distance of center of mass from center of the square, center of the square. So in such a case, they are asking you find the distance from of the center of mass from the center of the square. So it does mean that the center of the square you should take as the origin. So center of the square, this I have to take is the origin. This is the origin here. So this I'll take as x-axis, and this I'll take as y-axis. Okay. Now this coordinate I'll take as 0, 0 for the square. And for the circle, this distance is x, this is 2x, this will be also x. So this will be x plus x 2x. So here the coordinate will become 2x comma 0. Now let's try to find the center of mass x coordinate. So if I use here x coordinate of center of mass, that is a1 x1 plus a2 x2 divided by a1 plus a2. A1 a2 was area only, and x1 is the coordinate of center of mass, x coordinate of center of mass, x coordinate of center of mass of square. I am using square as the first, and x2 is same x coordinate of center of mass of the circle, of the circle. So in that case, you see x coordinate a1 is the area of the square. Area of the square is 2x square, but its coordinate is 0 only, so I'll write 0. Second is the circle of radius r, so area will be pi x square, and distance is x plus x 2x, so I'll write here 2x divided by area of the square, that will be 2x whole square, and this will be pi x square. It will be pi x square. This term is 0 only, so I can write here this is pi x square multiplied by 2x, and here you can write 4x square plus pi x square. X square you can take common. This is the x center of mass, so you get here 2 pi x into x square, and here I have taken x square as common, so it becomes 4 plus pi. If you cancel x square, then you get here 2 pi x divided by 4 plus pi, and that is also the distance of center of mass from this two system. From this here only I have taken. So if you find that, if you have to find the distance of center of mass, then what you should do, you should take that point as the origin, and you can solve like that. So you can also, this is also the answer of distance of center of mass, distance of center of mass from center of the square, center of a square, and that will be the same answer. This is 2 pi x divided by 4 plus pi. Tell me if you understood this example.
Yes, sir, I've understood.
Please copy it.
Yes, sir, I'm done. I'm done copying also.
Okay. So this was few example we have taken. Now few more example, like if some part is removed or if some part is added, then how we find center of mass, that we'll discuss in the next class. Meanwhile, you just read the chapter, so that if you read in the first, then it will be good to understand. Okay.
Okay, okay.
Okay. Okay. Bye, Neil.
Thank you, sir.
Thank you.